Very good morning, good afternoon, good evening to all of you. My name is Bharat, and I'm over here representing InfosecTrain. And guys, this is one of our initiatives which we have started for our Cybersecurity Foundation course. And this will be our day one where we are going to basically talk about lots of things. So let me just basically start this particular foundation course. Let me just tell you guys what we have planned for this particular part of 1 month almost, which we will be covering in 32 days, 64 hours of content. So this particular initiative basically it's been brought to you by InfosecTrain, and we are one of the market leading, I would say, IT security and training companies in terms of consultancy and training. And over here, we are basically delivering one of these particular basic cybersecurity foundation course, which I believe will be helpful to any individual who is looking out for a change into their domain or who is willing to start into cybersecurity. So I guess this is something which is going to help all of you guys, right? And even to those who are already working, just wanted to quick refresher about the things to get up to date. I will say that this is something which is going to help you a lot in that particular part. So my name is Bharat, guys. I'm working as a SME Blue Team and a senior information security consultant with 10 plus years of experience and having more of, I would say, variety of knowledge into multiple domains of cybersecurity. So I did started my career as an offensive player, as a red team attacker, like red team part where we do mimic as an attacker, as an offensive player. And then I basically shifted my domain after being a good amount of time into the offensive side. I shifted my domain into the defensive side, where I did explore the operations, majorly the security operations and all the services of the defensive side, like incident response, forensics, threat intelligence, threat hunting, malware analysis, risk management, SIEM solutions, and consultancies. So these are pretty much things which I have basically focused upon so far. So let's do talk about today's part, like what we are going to start with. So this is our domain one, networking basics. This entire cybersecurity uh, foundation course has been divided into multiple domains. So we are going to start with networking basics. Then there will be we all as a team member we wanted to basically contribute to this initiative. So then there will be the next part which will be presented by one of our elite trainers, defensive security basics. Then we will be having offensive security basics, and then we will be basically moving towards basics of cloud computing because it is one of the necessary part. Then we'll move bit of towards the information security management, and that's how we will be wrapping up this entire 1 month of program, 64 hours in 32 days, right? So this is domain one, which we are going to start with today, where we are going to talk about networking basics. So this entire networking will be going around for 5 days. We are going to have 5 different days and five different topics, like more than 5 different topics into the networking side. So what I'm going to make sure to all of you is that in this particular, I would say 5 days of program, we are going to basically touch from the very scratch. Like we are talking right now on WebEx, how it works, what are the methodologies and technologies behind it, right? So that is something which we are going to talk about in these particular 5 days of networking basics. So our today's agenda basically just sums up four major points. We are going to talk about what is network. Essentially, most of people do know this particular part, but still we are going to cover it in bit detail. We are going to take certain examples of it. Then we are going to talk about network types, which are rather, I would say, the examples I was talking about. We are going to talk about various different types of networks. We might be using most of these particular networks already, but we might not be knowing it. So that's where we will be covering this. Then we are going to talk about networking models, or rather, I would say network models, right? Generally, there are basically models which you guys might have heard about is OSI model, TCP/IP model. So I'm not talking about those models up over here. Moreover, those are basically the working of network models, right? So moreover, we are going to talk about the model types. What are the networking model types? Then we are going to guys talk about methods of data transmission over here, right? So that will be our 2 hours of agenda and program. That is our agenda for day one. Let's start with the very first part, network. You might have heard about network. We do have networks in mobile phones. We do have networks in our devices like laptops. We do have various different places where networks are there. So network guys, if I do talk about when we are communicating right now, so don't you think we are basically having a network on which we are connected, we are having some shared resources where we are exchanging this particular voice for electronic communication, isn't it? So right now when we are talking to each other, that is something which we are connected over a network and you guys are able to hear me, right? So in a very layman's language, if I have to talk about network, what is network? I would rather say that network basically consists of minimum two, but more than two computers or devices that are linked to each other in order to basically share resources, right? Now resources can be anything like share resources. Let's say I want to share a printer. So two or more systems being connected to like one or more system being connected to the printer, right? Or CDs basically. Even if I want to basically exchange a file, let's say I want to exchange a file, so I can basically have a network for the same, isn't it? Or allow any electronic communication of two or more devices together. That's what we do call it as a network, right? So the computer on basically a network, let's say a device on a network can be linked via multiple ways, right? It can be tables. If it's a telephone, there can be telephone lines. We do have radio waves. We do have sats, that is satellites. We do have infrared light beams. So multiple things are there which we can have as a part of network. Make sense? So that is guys what we do call as a network. That's what team we do call it as a network, right? So it is basically collection of interrelated uh, devices. Now, don't you think that if I do remove the IT electronics from it, if we are basically having a connection with two or more people in our society, in our colony where we do live, don't you think that it's a network as well? Social network we do call it, isn't it? So collection of any two or more things together can be basically a network, right? If I do have more than two like if I am communicating with more than one person, there is one me and there is one another person. If we are having something in between, a connection, that is basically what we do call as a network, right? So similarly a computer network, if I do repeat it again, it is a group of computing systems that are connected together to allow any sort of electronic communication, right? And network can basically, it is the only thing which is basically keeping entire world connected together, right? Let's say if I want to basically send a file to a person sitting in United States from India, only because of network it is possible that I will be able to share the resources, I will be able to share the files, I will be able to communicate to the other person who is sitting next in any particular part of world, right? So it allows us to share the information resources like data, applications, office machines, internet connections, anything, right? So that is our major part of networks, right? Computer works on binary codes, 0 or 1, isn't it? So it's all about binary, 0 and 1. So when we do have this 0 and 1 team, this binary language is used by computers to communicate as well, right, with one another. It is always made up about many ones and many zeros that are arranged in certain orders to convey the exact message that computer is trying to basically speak or computer is trying to communicate, right? So that's how network is basically developed and designed in order to exchange or share the resources. Talking about our next part, network types. There can be n number of types of networks depending on my need, depending on my agenda. I can have multiple different types of networks, right? So network types basically will be involving variety of network designs which are being created together in order to basically understand what sort of requirement I was having and how it was being fulfilled by intercommunicating devices into multiple parts, right? So we do have LAN, that is local area network, WAN, that is wide area network, MAN, metropolitan, global area network, personal area network, campus area network, storage area network, right? Apart from it, yes, there can be some more. As I say, that network type will be moreover, will be having moreover dependency on the type of communication which I want to establish to the next party, right? So majorly it will be covered in all of these particular categories, but yes, network types are of multiple different varieties, right? So we are going to discuss all of these things bit more in detail, team. So let's start with the first one, that is local area network, LAN. Every time when two or more devices are communicating, they are using one of these particular network types in order to communicate, right? It is one of them which they are using in order to basically communicate from one part to another part, right? It can be maybe within a single premises, it can be maybe outside the premises, it can be anywhere in the world. Okay, so our first one, that is local area network. So local area network, LAN, it basically consists of devices, or we can say computers, and all the related devices that basically wants to share the information, but over the same communication line, right? So that is what we do call it as LAN, right? If I want to basically share a certain information, but over the same communication line, that is what I do call it as LAN. Let me tell you it's more bit more features of LAN, how it is basically being used and all. LAN basically will be consisting of two or more devices being connected, or multiple network devices being connected within a limited geographical distance. Let's say I do have my office on first floor, right? And in this particular first floor office, I want to basically share a network connection so that my colleagues can basically share the file from one system to another, right? So the devices over here basically are connected using multiple protocols for proper and I would say efficient data exchange, right? And efficient exchange of your services as well, right? So LANs basically does have a transmit speed which is relatively higher than any of these particular ones which you do see. The speed is a bit higher, especially if I do talk about higher speed. It does have higher speed than WAN and MAN, especially, right? And LAN also uses your private network addresses for connectivity, for network connectivity, to exchange your data and services, right? So it will be using the cables, right, for your network connections, which will be like chances and rate, I would say, of errors basically does get decreases in terms of wired as compared to wireless. So LAN mostly will be using your wired like cable connections, which will be decreasing the errors and the maintenance of your data security over the network traffic, right? So that is basically the features of LAN, right? Two or more devices being interconnected over a limited geographical area, right? Restricted to a particular geographical location like a office building or a single department within the corporate office, or even your home office. These days we are all working from home, right? So that is what we do call as LAN. So within this LAN team, we do have various different advantages and disadvantages if I do talk about. Of course, as I say, the transmission of your data and services will be higher than other network connections. That's an advantage, right? And your network server in LAN basically acts as a central unit for your entire network, isn't it? So these can be like advantages, but of course, with advantages comes disadvantages, right? So LAN will be needing a constant administration of experienced individuals or engineers for the functioning. Because if one goes down, the connection can, if your server basically goes down, the entire connection can be dropped, right? So constant administration of your function services should be there for the proper functioning, right? Of course, it will be complex when you add more and more devices up over there, and leak of sensitive data can be done because if there is an administration which is having a monopoly on your entire network, I would say there can be a probability of leaking up of your sensitive data because everything is passing through that LAN administration, right? So whomsoever is having the control of LAN administration does have the control of your entire network, and that can be a major disadvantage of insider, right? That maybe the data of entire LAN can be compromised and there can be a major data leak as well. So that is LAN, guys. Now next is, guys, WAN. WAN stands for wide area network, right? So a wide area network is one of the most expensive, not expensive in terms of monetary cost, but expensive, like expanded, right? Expanded type of network configuration. So unlike LAN, WAN is basically having multiple LANs belonging on the same network, right? So WAN is basically connection of multiple networks, I can say, all together, which connects the entire world, right? And WANs are basically restricted to the confines of your city limits. So it's not basically that it will be into your city limits itself, right? Example, the best example, let's say internet from which right now we all are connected, that is basically a wide area network. Some of you guys might be sitting in India, some of you guys might be sitting in United States, some of you might be sitting in Australia, some of you might be sitting in UAE, and me over here from India, I am communicating to all of you. That is basically over through a WAN, right? So WAN can extend to any area of the globe, right? For example, let me take one more example. For a WAN, let's say there is an organization with a corporate office in India and they want to connect to a branch located in London, right? They can do that in same WAN, and users in both the locations can obtain the access to the same data, same files, same applications, and can communicate with each other, right? So that is what we do call as WAN, wide area network. So the main draw of WAN is to basically provide you the facility for a long distance network connectivity. Understood? An organization basically uses WANs to connect to their branch offices, which are located geographically away from your headquarters, right? And it's not like that businesses are the only ones who uses WANs, right? Two-thirds of your globe's population uses internet, right? It is an estimated part which I'm talking about. So two-third of your globe basically uses the internet, which is world's most popular and largest WAN today, to this date, right? Since we all are connected, that's again we have already talked about the example of WAN. Now, again, as I talk about the advantages and the disadvantages, so WAN comes with moreover advantages and disadvantages both. So advantage, of course, higher geographical area and is used for large distance connectivities. It can also, like, second advantage can be, it can basically have radio towers or multiple different sorts of connect channels for the users to connect and communicate. Disadvantages, very high cost to set up and the support of, again, experienced engineers and technicians is being needed to maintain your network. And of course, it is less secure because it is very difficult to prevent hacking and debug a large network, right? So that is something which will be always there in terms of WAN, right? Benefits, large area covered, improved performance. Of course, it does have security. Dedicated links can be there, which can increase the safety of your network. But prevention to entire hacking, WAN will be, I would say, a less secure as compared to the other parts. Understood? So that is, guys, your WAN, wide area network. Next one is guys MAN, Metropolitan Area Network, right? So MAN again basically it's a network type of network which does have an interconnection of several lanes, but it will be limiting through a city, right? Or a town or a municipality, right? Mus- So these things basically can be the part of MAN. So like LANs, a MAN can have various wired or wireless connectivity options. It can be fiber optics, it can be Ethernet cables, it can be Wi-Fi's, it can be cellulars, right? So all of these things basically can be used in order to create a MAN-based connection, metropolitan area-based connection, right? So moreover, MAN is a type of network that covers the network connection of an entire city or a connection of a small area. Let's say I want to have not covering much geographical location. That is what we do call as MAN, right? So the area covered by the network is connected using multiple different ways, right? It can be wired networks, wireless also, right? For example, we all do uses ATM, right? ATMs to withdraw the money. Do you guys know that all these ATMs basically are ATM terminals, which are being connected to one major ATM gateway, which is being located as the chest branch of the bank, right? So all this network connection, like of all the same banks ATM into one city can be managed by MAN, Metropolitan Area Network, right? Again, if I do talk about advantages and disadvantages, it does provides data transmissions for multiple various different channels for devices, right? And apart from it, we can say that the network area which has been covered, that can be a part of entire city, and some other parts basically can be done using optic cables as well. Disadvantages, if I do talk about, there can be like, let me just cover, let's say municipal entire coverage, right? Can span through entire city. Efficient networking standards are there. High speed connectivity it can give because of fiber optics, right? Fiber optics, MAN will be moreover on fiber optics, which is one of the most popular form of MAN connectivity as well, right? So MAN's connectivity basically majorly it's on fiber optics because they provide safe and fast connection data rates. Understood? So what can be the use case of MAN where I will be using MAN? So same network available in several locations if I want to have, right? I want to available same network in several locations, right? So in LAN, I was able to have a network accessible in one location if I do have multiple locations, right? Let's say if I am in a big city, big metro city, I do have one office in one particular part, one office in another particular part, but I want to connect more than one offices all together. That there I can use MAN. Someone in chat basically said that government entities use. Yes, of course, government entities may also configure MAN to provide public network connectivity to the users, right? Like we do have municipalities where we do offer free public Wi-Fi's to the city residents, right? Using wireless MAN technologies. So that is basically in another example. Bank is another example, of course. Now talking about disadvantages of MAN basically there can be high probability of attack from attackers and cyber criminals since again it's a large network, right? It's not something which is small and limited like LAN. So there are more chances as compared to LAN that MAN can have an attack of, and we do need good quality of hardware and installation so that we can basically manage this entire MAN. And of course, guys, since we are using fiber optics, and you do know that fiber optics basically are costly, so the installation cost is very high for the MAN. So these are like three major from the list: local area network, wide area network, metropolitan area network, right? We are going to talk about global, personal, campus, and storage. So the global area network, GAN. it basically again, so it consists of various different interconnected networks over an again unlimited geographical area, right? So global area network covers more geographical area than your LAN and WAN, right? So multiple different offices, multiple different part that can be also called as global area network, right? So in terms of global area network, we will be having majorly the things which will be covering multiple different parts of our geographical boundaries, right? Let's say I do have one office headquartered in India, another office in London, then another office I might have in UAE, and then another office in Australia, right? When all of these particular offices does share the same network, same connectivity that can be set up using again global area network. Again, global area network covers large geographical area, which is being used to support, for example, you can say mobile communications, right, over a number of wireless LANs, right? When and again, both of them can provide us connections internationally without any geographical boundaries. So, without any geographical boundaries, when I do talk about, you can say, moreover, in terms of GAN, we can have like again internet can be part of GAN, right? So there is not major difference between the WAN and GANs. GAN can have multiple WANs into themselves together, right? So internet, however, it's not the only computer network of its own kind, right? There are internationally operating companies also which are using local networks, right? Which are having several WANs into them. For example, Fortune 200 companies or Fortune 100 companies. There are very big companies who might have multiple different WANs into their network, right? And when we do talk about one company's WAN being communicating to another company's WAN, that can be done over again, right? So there are companies which does have several WANs, and then any connect company computers, basically they can connect to any computer of their company across the world, right? GAN might use again fiber optics infrastructure, which will be very costly to set up, right? And then it can be combined using international undersea cables or maybe satellite transmissions as well. So moreover, WAN, which we discussed that it was connecting multiple geographical locations into one part, same as GAN is doing. WAN is unlimited in terms of principle. If I do talk about, GAN can have multiple unlimiteds together into that, right? When I combine two or more WAN together, you can say that that's my global area network. So next one is PAN, personal area network. All of you guys might have used mobile hotspots to connect to your devices at least one time. So in this personal area network, to enable the data exchange, like especially if I do talk about smartphones, tablets, laptops, your computers into an integrated network, and this can be basically in terms of wired, it can be wired in terms of PAN, right? Personal area network. One of the most common transfer, if I do talk about transfer techniques in terms of PAN is, you guys might have used pen drives, right? USBs to have a connection. So that can be basically an example of PAN. That's a personal network communication between your USB device and your device, right? A FireWire can be another example. So PAN basically can be using wireless USBs. We do have Bluetooth, we do have Wi-Fi's, Z-Waves, Zigbees. All these can be basically the example of PAN, right? So in personal area network, if I do talk about personal area network, it refers to, in layman's language, I'm saying one more time, it refers to interconnection of devices within a certain range of distance. Let's say someone can connect to a laptop, a mobile phone, like wirelessly via Bluetooth, right? That can be in one example. Or maybe I have to physically plug any device into any other device. That can be basically. So that is guys your personal area network. Next we do have is campus area network. All of you guys are campus graduated. Some of you guys might be still in your colleges, right? You might have seen where you do used to live in hostels, you were having internet connections or maybe wired connections to the computers in your dorms, right? In your rooms. Even in your libraries, you were able to access the uh, connectivity between your entire university's network area, right? So that is what we do call as campus area network, CAN, right? So in campus area network, we do have multiple different types of, like, moreover, you can say that in campus area network, a network basically being created by connecting LANs together within a specific geographical area. That's what we can call it as a campus area network, right? So all of your networking equipments and transmission medias are owned by basically your campus owner. Let's say I do have my college where I do have multiple buildings, right? Even I do have those buildings does have classrooms. Even I do have hostels, that is the dorms where students do live. I do have library. I do have cafeteria. When in connection between all these particular devices are being done, because each of them will be having LAN, right? There will be a separate LAN for the hostel. There will be a separate LAN for the buildings. There will be a separate LAN for the library. So when I'm connecting all these LANs together and I'm controlling it from one centralized unit, that is from my campus owner's part, that is what we do call as campus area network. So this is, guys, another part of your type of network, what we do call as campus area network. People do also call it as campus network, right? Instead of CAN, some people might call it as campus area network. When you're connecting those dispersed LANs together into one phase, so that is campus area network. Like MANs, campus networks or campus area network also extend the coverages to buildings in the close proximity, right? And the difference between two configurations like the campus networks can help you to connect the LANs within the limited geographical area. While if I do talk about MAN, because it is closely related to MAN, instead of LAN, it is closely related to MAN. The only difference between CAN and MAN is CAN can help you to connect to multiple LANs within a limited geographical area, and whereas MAN can connect the LANs in large area. I'm talking about in terms of area, in terms of, let's say, a city or a town, right? So MAN will be having all the LANs which you can have in a city or town, let's say a bank, and having multiple branches together in the same city or town, that can be part of MAN. But if I do have two buildings together and I want to manage the network, that will be CAM, campus area network, right? So campus area network can be from 1 kilometers to 5 kilometers, while MAN can go beyond or can extend up to 50 kilometers as well. Let's take one more example to understand LAN. LAN is basically when I'm having a connection into my one department. Let's say sales department is connecting all together, right? In an organization that can be over one LAN. Then there is operations team. They might be having one single LAN. When I'm using having multiple different teams which are having multiple local area networks, LANs together, and I want to manage them as a centralized unit, I can set up campus area network. Then guys, there is SAN, storage area network. If some of you guys might have worked in data center, you guys would be able to relate it. So storage area network, it's basically specialized for high speed network connectivity bit, network between your network access devices and your storage devices, right? So SAN basically it's a network that provides the access to your storage devices. You do have servers, databases, right? If you want to connect to those particular databases, you use SAN, storage area network. It can compose of multiple hosts, switches, storage elements, all these things together, and variety of technologies, topologies, and protocols can be there. And SAN may basically have multiple sites as well, right? So let's say I do have my data centered in one geographical location and I want to access those particular servers, data stores from one another geographical location, I can use SAN, that is storage area network, right? No, it's a dedicated high-speed network that connects your servers to your storage devices, right? It provides you the block level access to your data and allowing your servers to basically read and write from those storage devices at the block level itself. Something which we do use over there is what we do call as RAID, RAID storage systems. So that is one part, guys, up over there. SANs basically are mostly being used in enterprise level environments where high speed access to data is one of the major critical parts, right? Every organization do need high speed connectivity to your devices up over there. How you can use SAN in cybersecurity. Now, let's say you do have your file server, database server, mail server, right? You want to keep accessing this particular data all throughout the part. You're a big company, so you do have all of these particular servers which wants to communicate to your database real time. For example, anyone who is trying to log in, I need to check in my database whether the credential exists or not, right? So I need the high speed connectivity between my server file like login server and within my storage, right? So I will be using SAN, which will be having block level access, which will be giving the connectivity to my storage services. Like it can be RAID, it can be optical storage or any sort of tape library. So using my SAN as a protocol, I can connect my server to my storage devices. Let's say RAID is having my storage, like my database are being stored in RAID, right? I do have database in which username and passwords are there, for example. So any user who tries to log in via SAN, I can check whether the user's credentials are correct in my database or not, and that's how I can allow the access or not, right? That can be one of the examples for SAN, storage area network. It is dedicatedly tailored for your network specific environment to your servers, to your storage systems. It can be via switches, softwares, and services. So that is, guys, your SAN, storage area network. Next, we all are right now, if you do check your mobile phones, 90% of us will be connected to Wi-Fi, right? We all do have Wi-Fi's at our home, at our workplaces. So we do have something which we do call as WLANs, wireless local area network. So when we do talk about WLANs, these are wireless LANs which has surpassed your traditional LAN. It was moreover cabled one, right? But over here, in terms of popularity, of course, it has surpassed your traditional LAN, but wired LANs always remains more secure and reliable. As we have discussed already, wired LANs basically will be using physical cables like Ethernet and switches. And when we do talk about WLANs, right, they uses your wireless routers, your access points to get interconnected to your network devices via radio frequency waves, right? So we do have multiple different encryption mechanisms in order to secure these wireless networks because by default wireless networks are not secured at all, and in order to provide a good amount of security we do use security protocols and encryption, good amount of good amount of encryption standards to secure our wireless networks, right? So that is basically one thing. Wi-Fi's are one of the most common use cases of your wireless LANs, WLANs, right? We do use radio signals to connect to multiple devices in a single location, right? So Wi-Fi can be basically one of the examples for your WLANs. Okay. So these are, guys, majorly the types of networks which we had discussed up over here, right? All of them. WLANs and missing from this list, but yes, it's majorly the part of LAN itself, but I have covered it separately. This particular part, guys, is where we have completed two or major parts, networks and network types. We are going to talk about network models and data transmission, right? So when we do talk about networking models, we are going to talk about majorly in terms of network models. What are various different types of network models up over here? So in this, we are going to talk about P2P and client and server model, right? So most of us over here, maybe in our college times or maybe now, we all might have downloaded some sort of movies or games from torrents, right? Which is not considered as a, like we can say, which is not considered as at all a secure network, right? But the technology which these torrents were using were basically one of these particular network models itself. So we are going to discuss all of these network models bit more in detail up over here. So in this, we are going to basically talk about both of these two types network models, that is your peer-to-peer and then client server. So let's start with P2P. We do also call it as peer-to-peer network models. So in terms of peer-to-peer network models, guys, it is a type of networking architecture where computers are connected and communicating with each other directly without any need of any central server. When computers are basically connected to each other directly, that is what we do call as P2P network, right? 1980 to be exact is when this peer-to-peer networking model basically comes into the business, right? Followed by deployment in early 1980s of standing PCs basically. So in peer-to-peer network traffic, there is no central authority, then the own computer itself. Each computer control its own resources that communicates directly with the other computers, right? So using peer-to-peer network model in terms of operating systems communicate to each other directly. Let's say on my system, I'm hosting certain files and I'm giving directly access of my system or those particular resources or files directly to your system without any central server. That's what we do call as peer-to-peer network traffic, right? So entire network, like each computer on the network, basically it's responsible for controlling the access of its own resources, right? Since there is no centralized architecture in between, so these computers generally are known as nodes, right? Or the host on your network, which form a logical group of computers, and the users that share the resources are basically connected over a P2P, peer-to-peer communication. For example, there can be a peer-to-peer network traffic between a Windows, a Linux, a Mac OS desktop communicating to each other. So that can be basically one of the major reasons for peer-to-peer networking, right? So if all computers in your peer-to-peer network are running on Windows operating system, it can be basically shared in terms of file sharing. Generally, we do have network share access, right? So that is an example of peer-to-peer because each computer maintains a list of users and their rights on that particular computer will be allowing a user to access the network's local resources. So on Windows, if you do have network shares, you can basically say that that is an example of peer-to-peer network traffic, right? So using a particular work group, each computer can maintain list of their users and their rights on that particular computer, and then computer can allow the user on the network to access the local resources based on the rights being given. So that is what we do call as peer-to-peer network traffic. So generally, if you do download any sort of movies, any sort of games or softwares from even torrent websites, it is generally being said that these are basically very less secure or totally insecure. Reason being because torrents basically uses these two particular like this peer-to-peer methodology where there is one system which is directly communicating to your system. So there is no centralized authority in between who is governing that particular network access, right? So that's why the malicious or the attackers basically can host the malicious softwares on their system, which can have directly a peer-to-peer communication to your system, and that malware can be directly transmitted into your system. That's why downloading something from torrent is being said as it's basically not secured, right? That is one of the major reasons. They are very simple to configure. They can be used in any environment where technical expertise is not that much required. For example, hosting a web server, HTTP web server like HFS on my system, and then sharing those particular files to all over the people in my network. That can be an example of peer-to-peer network, right? Disadvantages, of course, there are several disadvantages. They are not scalable, first of all, which means that if peer-to-peer network grows larger, adding or changing significant elements in our network may be difficult, right? And it's not necessarily secure, meaning in simple installation, for example, data and other resources shared by a network user can be discovered and used by unauthorized people as well, right? There are certain ways how these things can be basically used, right? And they are not basically, moreover, I would say, practical for connecting more than few computers because it is too time consuming to manage the resources on your network. For example, you want to set up a file server. So a server in a computer basically will be hosting, there should be one service that should be hosting that particular data or resources on your device. Then file server basically will be having your uh, files folders of over there. Then you have to basically create accounts, and for each accounts there should be rights. So all these things basically becomes less manageable for us to manage into a large network. So that's why P2P is not something which is being considered a more, right? Then there is, guys, this next one, client and server. So you see this particular image, this one was peer to peer. Every device was connected to one another, right? Now in client and server, there will be one server, centralized server, one authority, which will be communicating to all the devices. So that's what basically makes a client server network model, right? So this is what it makes as a client server network model. So in this client server network model, which is also sometimes called as client server architecture or client server topology, this one, there will be basically an architecture where multiple clients or computers or devices will be connecting to a centralized server that provides various different services and resources, right? It offers basically your centralized management, which simplifies your administration. In this client server network model architecture, basically there will be one centralized repository or a directory or a database that can be managed by one or more servers, of course, and then it can be basically given the access of that particular thing to all the devices within our network, right? So there will be multiple clients which will be making request to one centralized server, and that server will be responding to all those particular service requests. For example, Windows servers basically controls your network access to the group of computers, right? That is generally being called as domains in Windows, right? Or Windows domain. So the centralized database that contains all the user account information and security related information for that entire group of computers. That's what we do call it as, guys, Active Directory, isn't it? So each user on the network has his own domain, right? And according to its own domain level account, it is being assigned by your network administrator. That is basically being kept in your Active Directory, right? It can be a local account, it can be specific to that particular domain, or it can be a cloud resource, or it can be a Microsoft account as well, right? So user on that signs on that particular network will be having the access rights, which will be in your centralized repository, that is Active Directory. and based upon your Active Directory domain services, the access to the data and the resources is being allowed to that particular user, right? So client server will be, for example, there is one centralized server, Facebook. Now it does have multiple different clients, right? You are accessing your own account on the Facebook. I am accessing my own account on the Facebook. So that's a client server network model. So over here, we do have centralized authority to manage our data and other resources for all the number of clients. And over here, we can even ensure that authorized access, user access are being there on the network, right? We can control what types of resources, what types of files basically a user can open, can read, or can access. We can restrict when, or even we can restrict from where users can access that particular network, right? We can basically write certain rules in this particular type of architecture that will allow the computers to communicate accordingly. And even in some situation, we can supply various different files to the clients from the server itself, even when requested by the server, right? So various different things, basically requests are being made from the client. Let's say you all are the client and I am your server. So whatsoever request you are making, I am as a centralized authority, I'm responding to those particular services. That's what we do call it as client server network. These are more complex in their design, and these are more complex in terms of maintenance as per your peer-to-peer networks, right? They offer many advantages over your peer-to-peer network. So using user accounts, your passwords to your network for multiple different resource access based role role based access controls, or you can say your access control based your network communication. All these basically can be the example of it can be set up inside your client server network architecture. So these were guys two different types of networking models. Now, after discussing types of network, why these networking models were important was because these networking models are the part itself which will be helping us to understand how devices do communicates to each other within these various different types of models which we have discussed, right? So networking models only it's going to help us that how these devices are going to communicate, right? There is one word before I do move ahead. There is one word topology. So overall, if I do say topology, guys, in a layman's language, it describes how the parts of the whole network works together, right? So whenever you are studying network, right, you need to understand both the physical topology of your network and the logical topology of your network, because topology is important. It will be helping you to understand two things. That is how your network works, and as a whole, how your network works together, right? So if I do talk about physical topology, I will just use this particular paint slide up over here to explain. We'll talk about physical and logical both. So physical topology, you can say that all of your networks hardware, it mostly refers to your networks hardware and how other devices like computers and any other devices and the cables basically fit together. I would say hardware side, right? So you can say entire of your networks, hardware, and how computers, other devices, and cables basically are being working together to form your physical network. That's what we do call as physical topology. Understood? Then there is, guys, logical topology. Like in physical, we were having hardware, and as the name suggests, logical is going to be a bit different. So it has to do with these softwares, how to access the network, how the access of network is basically being controlled, how users and programs will be gaining access to the network, even how specific resources they will be having access. Let's say I am a manager, so on network, what sort of access I will be having, how I will be accessing that particular network, what are will be the applications and the databases which I will be able to access. All these things basically will be the part of logical topology, right? So it has to go for the software side, I would say. So software and logical connectivity of network resources. You can say it's part of your network logical topology. How you will gain access, to which application you will gain, to which specific resources you will be gaining on a shared network. That's what your logical topology will be deciding. So these were like two things which I thought that you should be knowing, because when we are talking about networking models, topology is one of the common words which you will be hearing again and again, team, right? So that's what this third topic was. Now, fourth topic, methods of data transmission. Now, before proceeding to the methods of data transmission, data is information. Information can be something different, data can be something different, right? Raw. So raw facts or figures, basically it's a normal definition of data, and how you will define data in terms of network. So let me basically just explain you these few things. We do have devices, we do have physical medias, right? It is something which is off the topic, because all of these things basically will be having certain types of data being transmitted to each other, right? So we do have devices, we do have physical media, we do have network adapters, NOS, network operating systems, nodes are there, servers are there, network segments are there. We do have something which we do call as a backbone, right? We do have clients, we do have host. So all of these things are there, right? And between these things, majorly between these things, like your devices, physical media, server, nodes, your client, host, there is something which always keeps on going on. That is what we do call as data transmission. It is basically the reason why we are intercommunicating, so that we can exchange various different things, right? So data transmission generally happens between two or more different devices, right? And generally we do have internet, we do have intranet, right? Majorly these are the things which we do have up over there. So whenever we do have any sort of data transmission, right? So data transmission will be always between two or more devices, right? So let's do understand two different types of data transmission: the digital data transmission, the analog data transmission. Let's start it from very basic, very scratch, right? This is going to data is basically, you can say, the resource which you want to basically communicate. Right now we are talking, I'm giving you the information about network, so this is the data which I want to transmit to you, right? So in this data transmission, methods of data transmissions are going to help us to identify what methods are being used to transmit the data from one place to another. So as a network professional or a network engineer, you will be always expected to monitor your network performance, right? And you will be always expected to have a appropriate response time, right? As per, like, if you're working as a network engineer, all of you guys might be agreeing to this particular part, that you will be always expected to monitor your network performance in your response time, right? That means the manner in which your data is transmitted from, let's say, Bharat's device to Sam's device, right? So the manner in which data is transmitted between one node to another node on your network can significantly affect the network traffic and the performance, right? So when I do talk about how data is going to be transmitted, that thing is going to impact my network's performance. If it is slow, then network might be slow. If it is fast, network might be fast, right? So we need to understand the characteristics and the potential, I would say, effects of your network transmission methods or network traffic transmission methods which are being implemented on our networks so that we can support and understand the impact on our network of our data transmission, right? So in terms of data transmission together, it is just an exchange, right? It is exchange of data among different devices or computers through a network. Like when you give basically a call to someone, just in layman's language, do you guys know how does calling works? If you are basically giving someone a call, let me show you a easiest, simplest architecture. So let's say there is basically a person. So this person is basically, let's say in Delhi, and he wants to basically send someone message to someone in Goa, right? Or he wants to basically make a call. So the nearest tower to this particular person, that is base station, it will be basically sending the call to your PSTN, right? Public switched telephone network, which will be deciding the route to the person, and then it will be locating the nearest tower to that particular person, and that nearest tower basically will be signaling your phone that the call is coming. And when this conversation is happening, there is one protocol which you all might have heard about, VoIP, right? This VoIP protocol is being used, and within this VoIP there is two protocols. The one is SIP and the one is RTP. When you call someone, if the ring goes, right, or if the phone is switched off, right, if you are hearing the caller tune, all this is because of SIP, session initiation protocols, responsible for connecting your call, starting your call and ending your call. Session initiation protocol. As soon as call gets connected and you hear the voice hello, that is because of RTP, real time protocol. These days we are using SRTP, secure RTP, so that communications can be secured. So SRTP or RTP is being used to exchange the voice and data. Right now, if you are able to hear me, it is because of SRTP. Understood? So that's how generally your calling works. So this data transmission, SIP, SRTP data transmission, it involves transmission of voice, transmission of data, and even sometimes, like it's not just about calling, I'm talking about data transmission as a whole, even non-voice information. Let's say I send you some sort of image, graphics, audio, text, or video over the network, right? So anything which is being transmitted or exchanged from one network to another, that is what we do call as data transmission. And most of your data transmission takes place through the networks, and the term data networks basically is synonymous as networks, right? So that is what we do call as, guys, call as data transmission. So as soon as the data is being generated, in some cases it is to be transmitted as soon as it's being generated. So in that such cases, data is instantly basically converted into network compatible format and transmitted without being stored either in your main memory or either on your disk. That's why we do have specific tools to capture that data traffic, right? So when we do talk about data transmission, the one is based on digital signals and the one is based on analog signals. So signal, basically, rather than saying digital data transmission, analog data transmission, I would say digital signals and analog signals. Now, what is a signal? Basically, you need to understand that first. So signal, you can say that is a data that is being transmitted as an electromagnetic pulse, right? Across your entire network, any network medium. It's an electromagnetic pulse which is being sent across a network medium. It can be analog, or it can be digital. Analog, that means it's a continuous wave, right? Analog means continuous waves are being sent, or digital, which uses discrete values, right? So we are going to discuss both of them over here. Let's start with let's start with analog first, and then we can come back to digital as well, right? So analog signals basically are these are basically being sent in terms of waves. Can you see guys this particular waves, right? Continuous waves of your electromagnetic or optical energies are being sent in terms of analog signals, and the intensity of signals is generally being measured in terms of volts, right? And if I do talk about digital, to be exact up over here, it can only have one discrete value, right? It can not one, it can only have a discrete value like 0 or 1s, or some specific voltage which represents the presence of any signal or the absence of any particular signal, right? So the sequence of zeros and ones in digital data are being translated into digital transform, and that's how it's being sent. So as I mentioned guys, analog transmission basically uses continuous signals that varies on amplitude, that varies on phase, or another features which are proportionally being used to variable, let's say to transmit any voice or to data or a image or any sort of videos, right? Of course, like VSETs, RF links, right? So generally you do hear FMs, right? In your cars, in your mobile phones, you do have FMs, radios. So that is an example of analog data transmission, right? So there is an analog source using an analog modulation techniques like FM or AM. It might be basically, it might involve no modulation basically at all. So in terms of analog data transmission, there is amplitude, distance through of wave from the midpoint of your waveform, right? This particular part, this thing is what we do call as amplitude, right? Is amplitude is the one half of your overall distance from its peak through the wave, right? That's what we do call as amplitude. There is something which is also known as cycle. Cycle is one complete oscillation of your analog signal going in and out. There are frequencies. Frequencies generally people do understand it. It has been measured in terms of hertz, right? Which is basically one cycle per second. Frequency can also basically a period between. It can be also called as a period of a wave. That can be also called as a frequency, right? So in analog data transmissions, we do have waves being sent, continuous waves, and that will be basically one of the parts of analog. And there will be wavelengths, distance between two successive crests through, that is what we do call as wavelengths as well, right? So these are terminologies which are being used in your analog signals, right? Or analog data transmission. Now coming to your digital. So digital transmission basically as I mentioned earlier, digital transmission uses voltage differences to represent the ones and zeros, right? So there will be a different volt for zero, there will be a different volt for one, right? And various different encoding methods are being used to convert your data into digital waveform, and each bit basically takes a predefined time to be transmit, right? And the sender and the receiver basically synchronizes their clocks, right? The sender and the receiver synchronizes their clocks, and that's how the bytes are being transferred 0 1 0 1 0 1, encoded, being said in digital waveforms, and then decoder is there which converts the digital waveforms into digital data, and it's been received by the receiver in real time, right? So the reason why do we sync the time clocks, basically it's because the pattern, like we do synchronize our clocks either by transmitting the bit pattern which we do have, or by monitoring the reception of your first byte. You can basically sync your clocks and accordingly it can be transferred, right? So digital can only have a discrete value in terms of zeros or ones, and it can be managed. Zero will be having a different voltage, one will be having a different voltage, and the sequence of zeros and ones is the digital data that will be translated into these waveforms using encoder, and will be decoded these waveforms using decoders. So you can say one, it can be a positive or a negative voltage level, and zero can be on a different voltage state, and accordingly it is basically being converting your entire data into this binary part. Clear? So that is, guys, what we do call as digital data transmission. Okay, so consider it in this way, like if you are using digital data transmission, in terms of digital data transmission, your data is basically in forms of zeros and ones. It is being converted, like zeros and ones cannot travel from one part to another. Computers do understand zeros and ones, so we do use encoders to convert that zeros and ones into waveforms, right? This particular digital signal which you are seeing up over here, right? It converts it into the waveforms, and these waveforms are further being decoded on the receiver's end and then being decoded in the same digital data which was being used for transmit, like which was intended to transfer, decoded, and the receiver system understands this zeros and ones, and that's how communication or the data basically it's being transmitted. Of course, there can be multiple different transmission methods, like there can be unicast, there can be broadcast, multicast, anycast. So multiple different things basically can be the part of data transmission, right? And transmission speeds will be varying again. It can be based upon bit rates, right? It can be based upon baud rates, right? So that is something which further you can deep dive into this particular data transmission as a topic. So this was, guys, our part and our intention of this entire agenda for today. That is networking models, methods of data transmission and all, right?